From space, our blue planet reveals a secret. Those swirling patches aren't just clouds. They're massive collections of plastic oil spills scarring the surface and invisible chemical plumes flowing from our coasts. Every year, millions of tons of plastic and chemical waste pour into our oceans. This isn't just an environmental problem. It's a direct threat to our food supply, global biodiversity, and even our own health. But in the face of this immense challenge, a new wave of innovation is rising. Today, we're diving deep into the groundbreaking technologies that are turning the tide on marine pollution, offering real, actionable solutions. Plastic waste is the most visible scar on our oceans, but the fight against it is getting smarter and stronger. Imagine massive floating barriers strategically placed in ocean currents, funneling plastic into collection zones without harming marine life. Now add AI-guided drones to the mix. These smart spotters fly over the ocean, mapping pollution hotspots with incredible accuracy and directing cleanup vessels to where they're needed most. But collecting the plastic is only half the battle. The real game changer is what happens next. This recovered plastic isn't just discarded, it's transformed. Through advanced recycling, it's reborn as durable construction materials, innovative textiles, and even new consumer goods. This creates a circular economy, a closed loop where plastic waste is given new value and never gets a second chance to pollute our seas. But what about the pollution we can't see? Microplastics, tiny fragments less than 5 millimeters long, are everywhere in our water, our food, and even the air we breathe. They are a silent, pervasive threat. The solution here isn't just about cleanup, it's about prevention. Innovators have developed advanced nanofiber filters that can be installed in wastewater treatment plants, acting like a superfine sieve to catch these minuscule particles before they ever reach our rivers and oceans. To make this even more effective, real-time sensors are being deployed to monitor microplastic levels, telling us exactly what kind and how much is flowing through our water systems. The ultimate goal, however, is to stop microplastics at their source. Scientists are creating biodegradable alternatives to the microbeds found in cosmetics and redesigning polymers to prevent them from breaking down into harmful fragments in the first place. By tackling this invisible invasion from all angles, we can drastically cut the flow of microplastics into our oceans. When an oil spill happens, it's a race against time. These environmental disasters can devastate marine ecosystems for decades. But today, technology gives us an unprecedented advantage. Satellites now monitor the oceans around the clock, using specialized sensors to detect the size and spread of a spill almost instantly. This gives response teams a critical head start. On the water, autonomous oil skimming robots, guided by AI, navigate the slick and efficiently collect oil from the surface, working 24/7 without putting human lives at risk. For the oil that can't be skimmed, a different kind of hero arrives: bioremediation agents. These are naturally occurring microorganisms that literally eat the oil, breaking it down into harmless components. Drones can deliver these agents with precision, accelerating the natural cleanup process and minimizing long-term damage. By combining rapid detection, robotic collection, and biological breakdown, we are revolutionizing how we respond to oil spills. Beyond plastic and oil, a quieter but equally dangerous form of pollution seeps into our oceans: chemicals, heavy metals from industry, pesticides from farms, and excess nutrients from fertilizers create toxic environments and trigger massive algae blooms that starve the water of oxygen, creating vast dead zones. The solution is an integrated, multi-layered approach. For industrial sites, advanced pre-treatment systems now strip out harmful toxins from wastewater before it's ever discharged. But we're also turning to nature for help. Man-made wetlands and biofilters are being constructed to act as natural kidneys for our waterways. Using plants and microbes to absorb and neutralize pollutants from agricultural runoff. Paired with precision farming techniques that reduce the amount of fertilizer needed, we can effectively stop this chemical cocktail from poisoning our marine ecosystems. This is how we balance human activity with the health of our oceans. Pollution doesn't just poison the water, it destroys the very foundation of marine life. The habitats, coastal erosion, accelerated by pollution and climate change, is wiping out vital ecosystems like mangroves and coral reefs. But here too, technology is helping us rebuild. AI-guided drones are being used to plant thousands of mangrove saplings in a single day, restoring natural coastal barriers that protect communities and absorb carbon dioxide. In the water, we're building new homes for marine life. Artificial reefs, some even created with 3D printers, are being deployed to provide complex structures where fish, corals, and other organisms can thrive. These 3D printed designs can even be customized to mimic natural reef formations, speeding up recovery in areas that have been severely damaged. This isn't just about cleaning up, it's about actively rebuilding a more resilient and vibrant blue planet. To win this fight, we need to know our enemy. We can't manage what we can't measure. That's where a vast network of smart technology comes in. Fleets of autonomous buoys and underwater sensors are constantly collecting data on everything from water quality and chemical concentrations to the density of microplastics. This information is streamed in real time to data hubs, where artificial intelligence gets to work. AI algorithms analyze the data, identify patterns, and create predictive heat maps that show where pollution is likely to accumulate next. This allows governments and cleanup organizations to stop reacting to disasters and start preventing them. By knowing where to focus our efforts, we can deploy cleanup resources with maximum efficiency, getting the biggest impact for every dollar spent and every hour worked. This data-driven strategy is the brain behind the brawn of our ocean recovery efforts. Ultimately, technology is a powerful tool, but it's not a silver bullet. The true path to saving our oceans lies in collaboration. It requires a global team effort, connecting governments, industries, scientists, and citizens. We're seeing governments enact policies that incentivize sustainable materials and hold industries accountable for their pollution. We're seeing corporations join forces to redesign packaging and create more sustainable supply chains. And critically, we're seeing the rise of citizen science, where everyday people use apps to report pollution, adding millions of data points to our global monitoring network. International programs are coordinating cleanup efforts that cross borders because pollution doesn't recognize national boundaries. When we combine cutting-edge technology with collective human action, we create a force powerful enough to drive real, measurable change and heal our oceans. The challenge is immense, but so is our capacity for innovation and our will to act. These emerging technologies, powered by a united global community, offer a clear and realistic pathway toward a future of healthy, thriving oceans. The vision of clean seas is not a distant dream, it is an achievable goal. With continued innovation and unwavering commitment, we can make it our reality. Thanks for watching. If you were inspired by these amazing innovations, don't forget to like this video, subscribe to our channel, and hit the notification bell so you don't miss our next deep dive into the solutions shaping our future. Let's protect our blue planet together.